So today we're looking at different methods to solve systems of equations besides graphing or drawing a table, which can be quite cumbersome. And that's kind of what these first few questions that I blocked out talk about. And we don't need them. So let's take a look, starting with question 5. Now, there are two different algebraic methods for solving systems of equations. And so let's take a look at those really quickly. The two types of methods of solving systems algebraically are as follows. And let me type those in. Okay. The first one is called the substitution method. Whoops. Substitution. And the other one is called linear combination, which is interesting. When I was in school, we didn't call it linear combination. It was called elimination, and we'll find out why that is. Okay, so those are the names of the two algebraic methods used to solve systems of equations: substitution and linear combination methods. Okay, so you have to ask yourself, so there are so many different ways to solve systems of equations. What's the advantages of using the algebraic methods that we have? Well, the nice thing about solving systems algebraically is that it's quicker than graphs or tables. Of course, if you have a really nice graphing calculator, it's not so bad. You just type it into your calculator and out it comes. But if you have to graph something by hand, and you might have to do that on a test at some point, that might be a particularly huge pain in the neck. So you can get the solution really quickly. And the other reason is that so it's quicker than graphs or tables, and if the system involves fractions or very large quantities, then you know that if fractions are involved, there's more math work involved. And if you're dealing with large amounts of numbers, large numbers, then graphing and a table, you could spend hours on one system trying to figure it out. So that's why solving systems algebraically is so much better. Okay. Now, let's move on to the next question. We're going to complete the following statement to describe these equations. Okay. So what we have here, you might be familiar with these. These look exactly like when we were talking about the werewolf family that was vacationing, and the pool happened to be a rectangular swamp. And in this case, well, we had 2L plus 2W equals 124. Remember, that was the perimeter equation. And then the length of the swamp was 10 less than 5 times the width. So, but together, the two equations that you see here that model this situation, they form, where is it? Well, I guess I'll have to write it because it's not going to let me type it there for whatever reason. So these two things form a system of equations Please make sure that you're following along in your book. And in how many variables? Well, how many variables do we see? We see 2 variables. All right, so we've got system of equations in 2 variables, and we won't need these. Okay, perfect. Now, I want to show you something here. Let me go back. And I actually have a video in Agile Mind that I'd like you to watch. So I'm going to switch my screen, and I'll be describing what it is that you're seeing in the next one, so that number 8 will make a lot more sense. Okay, so let's get to the video. I will do a new share.
Mr. Ian,
Yes,
may I restart my computer?
absolutely. All right. So hopefully you're seeing the screen that I'm seeing where it says the substitution method is one way to solve systems of equations for the swamp problem. One variable, L, is isolated in the first equation. So we see that L equals 5W minus 10. If I need to enlarge this, let me know. I think I can. Perhaps that'll make it easier to see. Yeah, let's do with that. Okay. All right. So one variable L is isolated in the first equation. So we are going to substitute the expression 5W minus 10 from this first equation for the L in the second equation. So when we see that L is 5W minus 10, then any place we see L in the other equation, we can simply substitute it. So pay careful attention. All right, so you can see 5W minus 10 is L. So we substitute it for L. So now it's 2 times the quantity 5W minus 10 instead. So now all we have to do is solve this equation, which only has one variable. So let's take a look at how we do that. So the first thing we need to do is distribute the 2 into the 5W minus 10. So 2 times 5W minus 2 times 10 becomes 10W minus 20. And then you still have the 2W equals 124. We combine the like terms of 10W and 2W to make 12W. We subtract the 20 from both sides, and we end up with 12W equals 144. And now we divide both sides by 12 to find out exactly what W is. And 144 divided by 12 is 12. So the width is 12. Great. So now we know exactly what 12 is. So we've substituted 5W minus 10 for L. We solved for W. Now what we have to do is take W equals 12 and substitute it into the equation to find exactly what L is. So let's take a look at that. So if W is 12, we just put 12 back in for W in the other equation. And 5 times 12 is 60. 60 minus 10 is 50. So we know that the length is 50. Now that looks like it might be complicated, but it really isn't. And the best way to master this is to keep practicing it. So the solution to this system is L equals 50 and W equals 12. Then if we put this back into the context of the problem, the length of the swamp is 50 feet and the width of the swamp is 12. Okay. Whew. All right. Now let me get back to the the book page that we were working on. Okay. So to answer these questions that we see here, for this one, it says, what substitution was made in the second equation? 2L plus 2W equals 24. If you remember, the first substitution was to take 5W minus 10 and substitute it for L. So if I can type that in, 5W minus 10, whoops, 5W, not percent. 5W minus 10 was substituted for L in the second equation. Okay. Then, after the substitution was made into the second equation, how many variables were left in that equation? Well, after we substituted 5w minus 10 for L, there was only one variable that was left. And that variable was W. Okay. And please remember, anytime you have a question as we're moving along, feel free to ask, and I would be happy to stop and address your question. Okay, now, in the solution shown in question 2, the value for W, which was 12, was substituted into the equation L equals 5W minus 10, so we could find the value of L. So now we need to verify that you get the same solution if you instead substitute 12 for W in the other equation in the system, 2L plus 2W equals 24. And so we know at this point how much everything is, right? And so this is what they did. Remember, whoops, let me draw here. 2L plus 2W equals 124. And with that, then we say, okay, 2L plus 2 times 12, because that's what we found W to be, equals 124. And 2 times 12 is 24, so that's 2L plus 24 equals 124. Now, when we subtract 24 from both sides, then we get, I'm going to move over here, 2L equals 100 because we subtracted that 24. And then, again, we divide by 2, and then we get those canceling out, and I get L equals 100 divided by 2, which is 50. So then all we have to do is check the solution in number 10 for L equals 50 and W equals 12 by verifying that these two values make both equations, true. And so back to the original equations, right? L equals 5W minus 10. Come on, let's write. There we go. 5W minus 10. And since, again, oh, there, come on. We know that L is 50. And my pen, there we go. L is 50. And 5 times 12 is 60. 60 minus 10, right? 60 minus 10 is indeed 50. And 50 equals 50. And the other equation was 2L plus 2W equals 124. And we figured L was 50, so that's 2 times 50 plus 2 times W was 12, 124. 2 times 50 is 100. 2 times 12 is 24. Does that equal 124? Yeah, 100 plus 24 equals 124. So all we did was verify. We checked the solution to make sure that that is something that we know how to do. All right. So moving along to question number 11. It says, write down the steps for using the substitution method to solve a system of equations. All right. So let's go back and review the steps, okay? I'll type this. That'll make it easier. Okay, let's review the steps. Step 1. You're going to solve either equation, for one variable, in terms of the other variable. Now that seems weird, but with practice, it gets easier. So if you've got something like what we had before where it said L equals 5W minus 10, well, in the other equation, all we had to do was substitute that 5W minus 10 any place that we saw L. That's why it's called the substitution method. The second step then is to substitute that expression into the other equation to get an equation having only one variable. Whoops, equation. To get an equation having only one variable. So in that second equation, we only had W that we had to solve for because we had substituted that one expression for the L. So the L disappeared, and then we had an equation that just had all W's for the variables. Then what you do is, if you've got that taken care of, you solve that equation for the one variable. We were able to find out exactly what W was, and W was 12. Then there's a second substitution that you have to do. And make sure that you're writing this with me in your book as you go, because I will be expecting you to have this written down. So if we're going to substitute this solution, whoops, sorry about that, that we found, like W equaled 12, and we're going to substitute that into either of the other equations, or the original equations, to solve for the other variable. Okay. And then, of course, you always want to make sure to do this, because not everybody does, but everybody should. You want to check the solution. For both variables in both equations. Okay. Now, do I need to enlarge this at all? Is it hard for you to see? I mean, I'm more than happy to enlarge it. Take it up to the side. There we go. Maybe that'll help. Okay. Now, this seems like a really good place for us to stop, because moving forward, we will be looking at actually solving systems of equations. So make sure that you have everything here written down in your book. On Monday, we'll start in with solving systems of equations using the substitution method. All right. So you guys have a great day and a great weekend. Don't forget to be awesome.